Hi students, welcome to Unit 2, Lesson 3. We're going to study the endocrine system and studying the brain. In this lesson, we will describe the function of the endocrine system, their glands, and their interaction with the nervous system. We'll also identify methods and tools used to study the nervous system. We start with the endocrine system. The endocrine system is a chemical communication system. The endocrine system uses glands to secrete hormones which then travel into the bloodstream. This contrasts with the nervous system because the nervous system has the peripheral nervous system where our neurons travel very quickly. It does not take much time for my vision to register, sight to send a message to my brain, to my hand to move. So the difference between the nervous system and the endocrine system is the fact that the endocrine system is much slower because the glands and the hormones get released into the bloodstream, but they are much longer lasting than, say, moving my hand because of vision. You might have noticed this with fight or flight. So the endocrine system consists of many different glands, including the pituitary gland, the thyroid gland, the adrenal glands, the testes, and the ovaries. So let's talk about the pituitary gland. This regulates growth and controls the other endocrine glands. It is sometimes called the master gland. It is in your brain. It is regulated by the hypothalamus. The pituitary gland is what is maybe not active when you have a smaller freshman that has not reached their growth spurt just yet. You see that with boys sometimes. And the thyroid gland produces thyroxine, which is responsible for regulating our metabolism. Metabolism is turning food into energy. Thyroxine and an overactive thyroid gland could lead to people who are super skinny because they have really high metabolism versus ones that have hypothyroidism, where their thyroxine is in deficiency. So they may be a little bit heavier or overweight. The adrenal glands secrete hormones called epinephrine and norepinephrine, and they arouse the body in times of stress. Similar to adrenaline, noradrenaline, same thing, but remember that these are longer lasting. So if you get into that fight, flight, freeze situation, you may feel the effects of that linger long after the threat has gone away. Testes and ovaries, depending on whether you're male or female, produce testosterone, estrogen, and progesterone. And they are what determines whether or not you're male or female, based on exposure to testosterone while you're in the womb. These, of course, are your sex glands, sex hormones, and for females, estrogen can lead to primary sexual characteristics like enlarged breasts during puberty, and then progesterone helps to regulate the menstrual cycle. And then furthermore, we have methods to study the brain. So endocrine system, before I continue on, endocrine system, remember, is slower but longer lasting than the nervous system. If we have an accident, people capitalize on that by studying what happens to us. So we see the physical effects of brain damage, its effects on people, maybe vision damage, memory damage. We saw several case studies of that in Unit 1. Electrical stimulation is something that we saw when the electrical stimulation was sent to the motor cortex. Well, there's also people who have reported electrical stimulation that causes them to hear music, to smell things. So electrical stimulation is yet another way that we study the brain. This man is hooked up to an electroencephalograph, and these record brain wave activity. So we can induce slower brain wave activity when we rest, when we meditate, when we daydream. And we record that using an EEG machine. EEGs are used for especially sleeping and sleep studies. If a member of your family has been through that, they may have spent a night with one of those on their head. These are the measures of those brain waves, and we'll be studying more about brain waves and sleep when we get to Unit 11. Now, all sorts of different scans are used to study the brain, of course. First, we have a CAT scan, which is used to detect brain damage and measure activity as subject performs a task. So the person will be asked to identify the suit on a deck of cards, and then the data is then analyzed. In the 1970s, in 1977, the MRI was created, and here a person lies in a very powerful magnetic field and radio waves, and it creates 3D images of the brain. And you may have had one, on other parts of your body. I don't know, but a good way for us to detect tumors and such. Now, a PET scan, emission tomography shows activity in the brain in real time using radioactive sugar. So again, you can perform a task and the doctors can analyze that. And a functional MRI is a combination of these two, the PET and the MRI. All right, this slide is a video and we'll be watching it in class. It's one I've been waiting to share with you about Phineas gauge, and we'll get to that in class.